So for folks just arrived, so my name is Kun Peng. I'm part of the Stanford community and the management science engineering from the department, and also a VC investor, general partner at a fund called xBuilders. We do like two different initiatives. One like more on the AI side, on the tech side, called Stanford AI Builders. The other one more finance, fintech, and blockchain side is Stanford Blockchain Builders. So today we're excited to join the expert in the space, robotics and physical AI. That being said, to start off, I would like to let the panelists to do a bit intro of yourself and what you're working on in the robotics space. And then what do you think is the most exciting thing happening in the space? And also could be more like right now what happened, right? From attending several sessions, GTC, I heard Jason Huang said, what stood out for you as the most important exciting signal? I'd like Keerthana to pick up.
Hi everyone, I'm Keerthana. I work at Google DeepMind. I'm one of the research co-leads of Gemini Robotics. I work a lot on humanoids and manipulation. I'm very excited about world models this year, and I didn't go to GTC, so I don't know what's hot there. I just live nearby.
Yeah, I'm Ben. I worked at Physical Intelligence. Before this, I was at Boston Dynamics for about 6 years working on the Atlas Humanoid project. And before that, I worked on quadrupeds at MIT. So I've been doing legged robots for about 10 years and recently decided to take a break from them.
And I'm Ben. I've also been worked on AI research at OpenAI, but as like a month ago. But before that, I worked on a startup called KCL Labs. We made open source humanoids. It's pretty fun. And before that, I was doing AI research at Tesla and Facebook for a while. And I didn't go to GTC either.
Yeah, thank you. As you can tell, we have a lot of experts in the space and a lot of representing really good companies, pioneers in the space. So we'll dive into the topic. We already did quite some warm up with playing Katz on your Twitter. So let's get straight to it. On the humanoid side, so why humanoids, in your opinion, and what engineering principle guide us to the humanoid form factor? Do you think it's the right abstraction or is it just a convenient one? So basically, should robots be more like general purpose, like humans, or you think it's probably better like a specialized tool for special purposes?
So my take is that I think by definition of the word manual and automatic, everything that's manual work right now is done by a person. And so if you're working on intelligence that looks at solving like labor and physical intelligence in all domains, then you kind of have to stick to a form factor that's very general. I think a lot of robot form factors are going to exist and are going to be useful, but if you want to work on the AGI hard version of the physical intelligence problem, then you kind of need to have a handle on how humanoids would evolve. I also think that hardware is sort of like a frontier that you can push intelligence into, and the hardware needs to provide a very wide enough playground to push research into. And humanoids introduce very new research areas that are not possible on other form factors, like multi-finger dexterity, like whole body control. So I think there are a lot more unexplored problems there.
Yeah, I think in general, humanoids are not a very principled approach to general purpose robotics. I say this having worked on humanoids for a while, and they're a ton of fun to work on, but I think they probably don't make the most engineering sense. I think there are... Designing robots that fit into similar environments as people and have similar footprints as people makes a lot of sense, but I don't think that necessarily has to be a humanoid.
I think also probably humanoids are pretty hard to build, which makes it more fun. But I think basically the argument for humanoid is when Elon made decided to do the Optimus, that was a very like unusual thing to do, and because Elon is Elon, it caused a lot of like second order effects in the Chinese supply chain, and now it's a lot of the components for humanoids are rapidly maturing. There's like a lot of top-down push for humanoid robots specifically in China. Like as an example, there was a company that I was working with our startup that like they really wanted us to get it to walk. Like the robot design they were working on to walk, and it was like, why do you need to walk? Is it going to do anything for you? And it's like, no, we need to get like a building, and the government will give us a building if we can get it to walk. So it's like a very like exogenous factor, like pushing for humanoid robot adoption. Beyond that, well, maybe part of that is just like the real reason would be like Xi Jinping thinks humanoids are cool, which is a fine reason. I think humanoids are cool. They have like a product like draw that people just like can see it and it screams like that's AI. So, but I don't know if there's any like principled robotics reason personally.
Yeah, thank you for sharing. Quite interesting view on humanoid, not necessarily the optimal act. I think that's quite interesting take. And also, I think modern robot design, as we started to talk about physical AI, etc., is not only like the hardware performance and raw hardware manufacturing, etc. You probably need to consider a lot of the software side, the model side, the compatibility with AI training pipeline, like the ease of data collection, etc., etc. All very important to success modern day robotics. Kind of like panel shed some light on some of those aspects, like how hardware design could affect how engineers like later on train the model and collect data, etc. Whoever on the start, we need to start over.
Yeah, I mean, I think the most important thing, it seems like to me, more than robot morphology, like is it humanoid, is it something else, is what is the data that the robot can observe, and like are you collecting that data? Like things like wrist cameras, for example, on robots, that's a very non-anthropomorphic feature, but it's turned out to be extremely effective because a camera near the robot gripper can see what the fingers are doing, can see what's happening, and even though it's not easily human interpretable data like you could teleoperate through the wrist cameras, for example, it's very useful data for these models. And I think that style of thing is the most important type of thing to bake in at the hardware design stage, like making sure, one, the robot can do the tasks that we want to do, in an ideal environment, and also can it collect the data that models will need to execute these tasks and see what's going on and have enough information to act on.
I think reliability and repeatability are important factors. If you don't have a reliable robot, you're not going to collect a large amount of data. And if you don't have a repeatable robot, such as like tendon drives or like cables that extend over time, then if you replay the data set, it would not necessarily result in successful trajectories. And over time, you would be invalidating your data set.
So the modern like machine learning stack is pretty much like 3 parts you can think of. Is like one is the big pre-training part. 2 is like pre-training would just be like how do you get as much information from as much data as you can get, and like there's more pre-training data available than any robotics data that anyone could collect. So like you just scrape the internet or like watch all of YouTube videos. There's a huge amount of data there. And then 2 is like fine-tuning. So maybe it's very much like the Kun like cake, if anyone's ever seen that. But it's like the supervised learning part where you have your higher quality data, in-domain data, it's on your robot. And like different people have different approaches to that. Like Sunday robot, Sunday has this like gripper thing that they collect a bunch of data and do inverse kinematics. Other people are collecting robot-specific embodiment data. And then like the third part, which is proven to be like increasingly important, is this like reinforcement learning part that you put on top. And like so once you have like a model that can like fairly, it's really like 95% accuracy on some task that you wanted to do, like how do you do the march of nines, and that's just like poor reinforcement learning on top of it. And I feel like in the robotics discourse, like right now, most people, when I think about like robotics embodiments as it pertains to that part of the like the robot stack, they're thinking about like the middle one, like the supervised learning one, collect a bunch of embodiment specific data for like doing your like fine tuning, and then they'll take some like pre-trained LLM and use that as the backbone, and maybe that's a good idea, maybe it's not. I think right now there's like a pretty open question of like what's going to work like once you've got those two figured out, like in the RL world. Personally, I suspect that like Keerthana said, like the thing that matters is reliability. Like, can it actually do RL rollouts and like without breaking? I mean, Dyna has kind of demonstrated some of this already, and that might be a clue as to why like that form factor being good or not. I don't know. And I'm sure Pi has already.
Thank you for sharing some of the challenges and like repeatability, definitely reliability, and for such a complex kind of system, not only handling the language part, but the vision part, the action part, it's quite complex. That being said, I think integrating vision systems for humanoid could be surprisingly challenging. All right, so I want to probably dive a little bit there. Where, what do you think? What are some of the important considerations and features for modern training pipelines, particularly for the vision side of the humanoids? Anyone?
Yeah, there's a few things that come to mind. One is for humanoid-like things, specifically if you're teleoperating them. Something, especially if you're remotely teleoperating them, something that seems to be very useful is having the ability for the operators to move their heads and look around as they would in the real world. And that involves like generally adding actuators to the robot that it doesn't really need for its own sake, but that the operators need to be able to control to have a comfortable and productive time using the robot. So that's one aspect of that it's kind of more challenging than it needs to be from a pure robotics perspective. Like, you could just have a 360-degree field of view set of cameras on the robot, but that's not an easy thing to convey to a person operating the robot. Panning between that, around that view with low latency and in a comfortable way for the person. Another thing is, like I mentioned before, cameras that are distal on the robot. So at the gripper, for example, routing high bandwidth data down the links of the robot arm is a big challenge. You'll see lots of videos of robots with USB cables dangling around the outside of the arm. And that works for a one-off, that works for 100,000 cycles, but it doesn't work for 10 million cycles you need for the robot to actually do real things in the real world. So that, it's a very electromechanical problem, but just getting high bandwidth data to the ends of the robot is a huge challenge.
Yeah, so I think like a lot of the current robotics stuff is like still pretty slow. So you see like a lot of demos are sped up, or even the demos that aren't, they just feel like they're operating at like molasses speed. And so I think so when I was at Tesla, we actually did quite a bit of it's like self-driving is probably the field that has the most like latency sensitive vision applications right now, and like we did quite a bit of stuff to make sure that the vision systems were fast and performant, like even down to the like you want to remove the HDR filter because it's an extra like 5-10 milliseconds on the like a processing, whatever if you're converting to RGB, like that takes processing time both during training and inference. So neural networks don't really need to see RGB camera feeds. It's only for humans. So you can like send different, like you can do like a lot of hacks. And I think, frankly speaking, most of the robotics companies that I've seen haven't really gotten to that point yet, but I suspect that they will. Like my personal bet is that like at some point, you'll have to run this stuff in real time, and that's going to put more constraints on what types of stuff you can do. Like what does the product look like? If you're selling a $5,000 robot, like you probably can't put GMSL cables on it. Like you need to use whatever is commodity So maybe that means your cameras have to be close to your compute or something like that. So I think it's like probably like if I had to guess on what robots look like 2 or 3 years from now, it's going to be like, you know, first of all, like real-time vision systems starting to, you know, be pre-trained, like large pre-trained real-time vision systems, and the cameras and vision system will have to be a lot lower latency. You can't use like USB cables anymore.
I think one complexity with humanoids is that like you don't always see the entirety of your workspace compared to like an Aloha-like robot. So then your modeling problem becomes very non-Markovian, and you need then like memory or where you previously looked to have full attention over your entire space. So it's a slightly different and more complex modeling problem for learning. And secondly, I think it's a controversial topic, but and people have varied opinions about whether we need like depth sensing or more than just monocular cameras. Yeah, we don't know. I think different people have different hardware, so we'll see.
Yeah, interesting view on the vision side. I actually want to go to another side, which is I already kind of get your view or perspective. Some are not that optimistic to the humanoids to be actual form for or the best form for robotics. Do you think like Dexterity's hands are important for humanoids? And can current AI model architecture handle the texture hands? Whoever can start.
Yeah, I think hands are going to be useful. There are a lot of things hands can do, like opening bottles, like cooking things in an aesthetic way, etc. And I think it's a question of like, there is a lot of engineering risk. If you look at current hardware, like sure, grippers can do a lot of things, but you have to look at the gradient. And in the last 2 years, for example, a lot of hands have come on the market. And if you look at, I think in the next 2 years, it's going to be even more evident that hands will be more capable than grippers. And like the dexterity gap between hands and grippers are closing fast. Regarding AI, like Sharpa, for example, they had a talk at GTC, I think. They have a lot of work on like tactile AI. So I think, yes, current modern systems are starting to tackle them, but maybe we do need more. Like teleoperating them is not quite as easy as grippers. So I think the methods will also evolve.
I think like that's like it's kind of a non-falsifiable question, because like like maybe no one really makes money from robots right now, so like there's no way to say like, I'm sure like hands are useful for some things and other things, like if you're doing wear testing at a glove manufacturer, I'm sure hands would be really useful, but maybe that's not a very large market. Like so, and then too, it's like no one has like the ML system really ironed out. Like I personally don't see an argument for hands versus grippers versus any other manipulator. In the end, like it's all probably going to be some derivative of intelligence as a substrate, but hands might prove to be like really cool. Maybe someone wants to like. I mean, I know like when we were selling robots, like people would pay like a couple $1,000s for hands that were not that useful just because they looked cooler. So that's a good idea.
Yeah, I personally think engineering-wise, anthropomorphic hands are a pretty ridiculous thing to build. A test I've done of myself is going around my day with like limiting the number of fingers I can use. And if you go around like this all day, you can do basically everything but type on a keyboard. So I think the answer is probably somewhere between 1 degree of freedom pinch gripper and fully fledged anthropomorphic 5-finger hand, but it's not the anthropomorphic hand. Like it's something much simpler than that. And I think just because the fundamental building blocks are so different in robot hardware compared to biology, like we shouldn't be trying to do the same thing, and we should try to be taking advantage of the interesting features that robot actuators give us as opposed to biology. Like my hands are very range of motion limited. Like my fingers can't bend backwards, but like I might be able to do some interesting things with fewer fingers if they could. So like taking advantage of things like that, where possible is not copying what humans have, because that, just for the sake of copying it. I think there's a real argument on the learning side of like, maybe if you can somehow pipe all of the YouTube videos of everybody using their hands ever into your model and get the robots to learn how to use anthropomorphic hands from that. If that pipeline really works, and it really only works if the robot has a 5-finger anthropomorphic hand that can do everything a human hand can do, then maybe, but otherwise I think it's a pretty silly thing to build.
So I think the panelists in the previous question mentioned that just like data collection to train a model, especially it's very sometimes very slow and then it's very expensive. So the question could be a little bit controversial as there are different views here and there. So it's about simulation. What's your view on how far can simulation take us? Can we actually eventually use entirely simulated environment to train robotics? Or it can be more like hybrid, we still need a real world data collection to train.
Yeah, I think it will be hybrid. I also think like a lot of the simulation might become more like world models grounded in physics. I do think that like real world data is still going to be useful and would be needed to like ground the models. If you have like toy data, then you end up with toy intelligence, and that is like a disadvantage of like most only sim-based methods right now.
Yeah, so I think like I was saying earlier about the 3 layers of intelligence, like the simulation, it really is for the 3rd layer, and actually like, when like at Tesla or like a lot of self-driving car companies tried training like say like the 1st layer part in simulation, and it really doesn't work. It's just like simulation, you don't get the type of like diversity that you need to be able to generalize to the real world. Like, but in theory, now that like the reason why it would be useful now is because you have a really strong general purpose model that's like providing the intelligence like substrate, and then you're like it's like supervised to some useful thing that works both in the real world and in sim, and then sim you can do your like RL stuff. I actually think that's a pretty compelling argument that's gonna actually work well. Like I have a friend is like Eric Jang is like the head of he was at AI1X, and he wrote this book called AI is Good for You, and chapter 8 is really good. It's about this theory called jungle basketball, where like his idea is that you could learn just general intelligence by having teams of agents play jungle or play basketball in the jungle with like jungle rules, so they can like kill each other. So and they would naturally learn communication, like just all of the stuff you would need to have higher level intelligence. I think that's a pretty cool idea, and I would like to try it at some point. But like I don't know if we're there just on the sort of first 2 layers, but yeah.
I don't know that I really have anything to add to these 2 answers, but it seems like for a certain set of problems like locomotion, we can do those problems entirely in sim now. Like, if you look at Unitree's videos, their locomotion is incredible, like incredibly robust, can go over basically anything, and I think it's pretty much all trained in sim. But it seems like for anything more complex than that, at least with the state of simulators right now, that's not enough.
Yeah, there is another good reason to do stuff in simulation, which is that Jensen will give you money if you do. Like actually, I think robotics right now is mostly defined by what will Jensen give you money to do. So.
Actually, that's why I'm asking that question to your GTC. Maybe that's definitely very interesting in this. So actually, I want to give enough time for the network, and also probably have 5 minutes or so for the board to ask questions. So the last question, so we can prepare questions, so we can probably give like 2 or 3 people chance to ask. So last question from my side is, what do you think will be the biggest advancement in the field this year, and why? Whoever want to start?
Well, Why spoil the surprise? Why spoil the surprise?
Oh, I think by the end of this year, like you will be able to vibe code most physical things. And like basically what happened for software engineering like last year will happen for CAD and PCB design and everything, and that's gonna like really speed up iteration times and lower the barrier to entry for a lot of cool ideas.
I don't have a super high confidence in this, but I'm pretty hopeful that somebody out there will actually ship an interesting robot this year and deliver it to real customers.
Whoever you wanna just leave your okay.
My question is to you, Ben. So you have led Ben Bolte. Yeah, so you have led KSK, which is like the one of the best open source humanoid company there was. Similarly, right now there's a lot of open source egocentric data companies coming up. Like almost every high school grad, undergrad is trying to create a data collection company. What is your take on it? Like, what is your take on it? Do you think these kids will become successful, or is it a very saturated market?
Okay, I think. Okay, so first of all, I think VCs in Silicon Valley are a bit like the bad guys in Moneyball, like the, the ones that are like, So the argument for like funding an egocentric video data collection company is pretty simple, which is like, in the event that it's a winner-take-all thing and physical intelligence and skill become the winners, you can just sell to them. In the event that it's not a winner-take-all thing, then you can bootstrap off of this data to build your own robot company. So, and it's a very like capex-like thing to do. So from why would if I were an investor and there was like a plucky undergrad that comes to me and like asked me for money for this, like yeah, sure. That being said, I think it's like very uninspired, and it makes me feel depressed. Like, I think that I wrote a blog post about this recently where I think basically like the influx of interest in robotics isn't really coming from anywhere. It's coming from the fact that like B2B SaaS is uninvestable, and a lot of investors that sort of made their bread and butter off of B2B SaaS are like, okay, where do I go? And undergrad, like if you're an undergrad and like suddenly Facebook's laying off everyone, you can't get a job at OpenAI or whatever, like, yeah, I would go do it. Like, I mean, it's a very natural incentive structure, but like, if you're asking about like, is it fundamentally a good idea? I have yet to see an undergrad collect more data than the internet has, and until that happens, I mean, like again, it's getting into that three stacks of things. Like I think the intelligence substrate is still, it's like there, and I don't know that you're gonna add a lot more. Like maybe in the interim, people will use it for something, but yeah, I don't know.
Thank you. Ben, being honest.
Can you guys hear me?
Can you put it closer to your mouth?
Oh, so my question, actually, like there's like a good mix of hardware and software people. That's a good division. So I'm curious to hear your views on, like people are building companies in which there is hardware and software component, and people are building companies which are only software. So, what are your guys' thought on? Do we need a co-design of the hardware and software to have the robot intelligent enough to sort of act in the world, versus we could have a company just do software and that's enough to have just a variety of things coming from.
I think in the limit, you probably don't need companies doing both. Like, if somebody really does have a magic model that can control every robot to do everything, like they don't need to build the hardware. But I think in the meantime, there's a lot of benefit to that sort of co-design, and for a software company having control over the hardware they're using and being able to iterate on the hardware quickly, and really understanding what their models can do and how the hardware can be improved to improve the models.
Anything else? Hi. What are your thoughts on the killer applications once the infrastructure is mature enough? No, I will provide more context. Killer application is like in the text as code, there is always the infrastructure maturing, and then the application layers comes later, like the social network when it's getting.
Yeah, actually, I was thinking about that. So, like, maybe a good parallel here is why are the hyperscaler companies building coding models? Is coding the killer application for LLMs? I think a lot of people have sort of like been like, oh yeah, there's so much money in it. But you think about it, it's not necessarily the best application. And I think the basic reason was because the people working at OpenAI and Anthropic are programmers, and so the thing that they could make work really well was coding models. Like you had your LLM and you go start making it work really well. And I say this because like, you know, maybe that's kind of what holds up like making, you know, really, like I've CAD'd a lot, I've coded a lot. CADing feels like there's more like stuff to automate than coding. So why, but it's just because there's no like mechanical engineers working at these companies. So put differently is like, I don't know if there's like a killer application. Like the killer application is what you make it, right? So someone, like, it's not like this stuff just like happens. History doesn't like happen, you know? It's like people move history in one direction or the other, right?
Hello? My question is, what advice would you give to someone early in their careers? Maybe they are finishing a master's degree in mechanical engineering or mechatronics, robotics. What would you advise them to find their path into this future of creating the robots?
I think learning how to use the AI tools is going to be very important to iterate fast. Nowadays, you can like learn a lot by re-implementing papers with cloud code and stuff. I think that's a great way to like pursue projects. Also, yeah, just like building a lot of passion projects is a way to learn more and develop your own opinions rather than what is explained in papers.
Just to add a little bit to that, from a mechanical engineering perspective, I mean, we don't yet have the coding agents to build our projects for us. So actually building things yourself, designing things, and doing it yourself is the best way to get experience and develop intuition for what works and what doesn't work and how things work. So yeah, I can't recommend doing as much of that as you possibly can enough.
I don't know if this is like everybody, but at least for me, I've always felt very like self-conscious that I'm not that smart, and so I like kind of like leverage that to like get myself to work hard. You know, like you should, like I just like have this feeling like, oh, everyone else is like so smart, and at some point that shifted to like me also thinking like most other people are not that smart either. Not that I'm much smarter, but it still is like I feel like that's kind of like if you always like feel like a little bit self-conscious that like, oh, you know, like there's this really cool thing happening and like other people are like thinking through things. I feel like that's a pretty good way to not like get full of yourself or something. I don't know.
Actually, you can also give some advice. I think even in Stanford, have a hard time finding a job. Like folks, if you don't get your like hand dirty, like trying to learn the AI tool. I'm more from engineering, software engineering side. I learn all the like coding stuff, which is not that hard to learn. So all the video online, you can learn yourself, and then you just self-immerse, GitHub, etc., and try different things. Then that will help you to find a job. And nowadays, even Stanford is not guarantee for internship, but you yourself getting immersed and learning things give a much higher chance to start your career.
Thank you for being here. My question is on the like right now we start to see like more model and a lot of like data layers that allow like physical AI to happen. But my question is on like thinking the technological breakthrough that would require for physical AI to happen. Would it be on the data layers, or is it more on like the physical side? And where do you see the mode in this area, and where do you see the applications happening? Like which industry do you think that like that's is gonna disrupt first?
I will say any answer that someone tells you, you should take it with a heap of salt. So, because depends on if they're trying to raise money for a startup. I think if they're not trying to raise money for a startup, they'll have some epistemic humility and just say like, we don't know, things are really cool and I want to build cool stuff. They are trying to raise money for a startup, I think, construction.
I think we need breakthroughs in like every layer of the stack because robotics is a very system problem. But I also think that intelligence is going to be like massively valuable. Like if you had told me AI would be so smart and capable like 2 years ago also, I would not believe. So I think the frontier is like quite deep even for physical AI. Other question, which industry would be unclear, we'll see.
Awesome, thank you, the panelists, for sharing your experience and perspective and also your question. And we just open the floor for networking, so just feel free to talk to each other outside. So thank you for your time, and thank you, panelists, for your time. Thank you.